blocked me on Facebook, and now you're going to die. Shit!
Hello, welcome to the hashing demonstration of the Practical Cryptography course. In this video, we'll be demonstrating each of the 4 requirements that a real hashing algorithm must meet. You'll also learn Linux commands that'll help you with the lab that you have next. This is a standard Linux terminal. The commands we'll be using in the next few minutes come with all Linux terminals out there, whether you're using Ubuntu or Mint or Debian or CentOS or whichever. This is actually the Linux terminal built into the Windows 10 operating system. In the current directory, I've got one file, mobydick.txt. If you look at the contents of this file, you'll see that it's a pretty long file. In fact, this is the entire text of the book Moby Dick by Herman Melville. If you look at the size of this file, it is 1.2 million bytes long, right? Approximately 1.2 megabytes long. We can use the word count utility to take a look at exactly how many lines, words, and characters are in this file. You'll find that this file is 22,000 lines long, contains 215,000 words, and 1.2 million characters. So it's a pretty big file. We can calculate the MD5 hash of this file using the MD5 sum utility. You'll notice that the entire 22,000 lines went through the MD5 sum utility and created an MD5 digest of this right here. Now, if I take a copy of this file using the CP utility, I'll have 2 files, each with the exact same size, exact same lines, exact same word count, exact same number of characters. If I hash both of those files, since they are exact copies of each other, we can see that they both have the exact same digest because they are identical files. Now, if I go into this second file and I make a very small change, I'll make this change somewhere in the middle. I'll just kind of hold down the page down button until I feel this is about right. I'm going to take this word right here, I'm going to capitalize the second letter, right? Create a very small typo. I'm going to save the content. And again, if you look at the word count, haven't changed the number of lines, hasn't changed the number of words, haven't changed the number of characters. Even the number of bytes, the files are still exactly the same size. Could you imagine how difficult it would be to determine whether these files are different? Having 22,000 lines to look through where only 1 character is off? One of the benefits of the MD5 sum utility, or really any hashing algorithm, is that you can very quickly compare 2 different files to determine that the files are definitely different. Notice the original mobydick.txt file still has the exact same hash that it had before. Nothing changed there. But the 1 character change that we did in mobydick2.txt changed the hash pretty drastically. So let's talk about some of the aspects of hashing that we discussed in the last lesson. So we said a real hashing algorithm must meet 4 requirements, right? We're going to start with this guy right here. Notice the 215,000 words in mobydick.txt, we changed a single letter, which is a very, very slight change to the original content. However, the resulting digest changed pretty drastically. You'll notice very few of the characters in the resulting digest match each other. The reason this works is hashing algorithms aren't simply just an iteration of a mathematical formula. What they typically involve is 1 iteration of a mathematical formula done over and over and over and over again. So in the very beginning, maybe a small change is only a small difference in the resulting output. But since you're iterating on that over and over and over again, at the end of the day, when you finally completed the entire MD5 algorithm, the resulting difference is going to be much bigger. This is also sometimes called the avalanche effect, where a small change in the beginning avalanched into a large change in the resulting digest. Moreover, let's talk about this guy. If I gave you that digest right there, would you be able to reverse engineer that into the entire book, Moby Dick by Herman Melville? Unlikely. In fact, it's impossible. That's one of the requirements of a hashing algorithm, is that when you give someone the digest, you're giving someone nothing, no hints, no clues, no information at all whatsoever as to what the original content was. A step further, if I also gave you the digest, it would be very, very difficult for you to create, other sets of 22,000 words that also add up to the exact same digest. That's one of the other requirements that a real hashing algorithm must meet. Cool, so this is how you would use the MD5 utility on files in the directory that you're currently in on Linux. But you can also use the echo utility to send text to a particular hashing algorithm. So if I use echo, I can echo hello to my screen, or I can redirect the output of that using the pipe feature to the MD5 sum utility. Now, we have this digest right here, which is the result of the MD5 hashing algorithm on the string hello. Now, if you're following along, do keep in mind, echo also automatically adds a return character at the end of the sentence. If I want to avoid that, I would use the -n argument. You'll notice here, there is no return character at the end of what was echoed to the screen. I can again echo that to MD5 sum, and again, you'll see that this hash is very, very different from this hash, when the only difference was simply the existence of the return character at the end. Moreover, I can add some letters to the beginning or to the end of the original message, hello. And even though I'm adding the exact same letters, ZZZ in both cases, the resulting digest is drastically different. The reason is ZZZ hello is still a different message than hello ZZZ. So the order in which I combine values in a hashing algorithm does matter. I can also add a whole bunch of text, and you'll notice that no matter how long no matter how much data I feed into the MD5 utility, the resulting digest is always going to be this long. That's an example of this last requirement here, that the resulting digest is always a fixed width. You notice these 5 characters created a digest that was this long, and the entire content of the Moby Dick and the modified Moby Dick book files also created a digest that was only this long. No matter what I fed into the MD5 utility, either way, the resulting digest was always the exact same size. Once again, the benefit of this is that the resulting digest doesn't provide any clues or hints as to how long the original data was. So that was an example using MD5 utility. You can actually do the exact same things using the SHA-1 utility, and that'll give you the SHA-1 hash. MD5 creates a 128-bit hash, SHA-1 creates a 160-bit hash. So you'll see that the digest is a little bit longer. If I run both copies of the book that I have through the SHA-1 utility, you'll notice both of them create exactly the same length digest, but obviously drastically different from what it was before. Some Linux utilities also have the SHA-256 sum utility. This is using the SHA-2 family of algorithms, specifically the algorithm that produces a 256-bit digest. These right here are the 256-bit digests of the book mobydick.txt and Moby Dick 2, which was the file where we capitalized that one letter. I hope this video was informative. I hope this kind of helped give you a practical understanding of these 4 requirements for a hashing algorithm, as well as showed you some Linux commands that you can use to do hashing in the real world. You'll be using a lot of these Linux commands in the next video in your lab. Thanks for watching. I'll see you in the next one.
You blocked me on Facebook, and now you're going to die.
Shit!